Now in this video we'll be looking at solving modulus inequalities. Now here we have an inequality. The modulus of 2x minus 1 is less than or equal to 7. One important thing to understand about modulus. Let's do a basic one. If I say the modulus of x is less than or equal to 7. And I have a number line here. Let's put 0 in the middle. Alright. We'll put 7 here. Let's put negative 7 there. What this means is that any value, a substitute for x, it either has to be less than 7 or greater than minus 7. It would have to be in this interval between 7 and negative 7. Alright? So, for example, if I put 6 here, then modulus of 6 is less than 7 or equal to 7. If I put 7 here, 7 more or less. If I put 5 here, it satisfies. If I put negative 6, the modulus of negative 6 is what? 6, which is less than or equal to 7. Alright, any value between. Let's say I put a value outside the interval negative 7 to 7. Let's say I put a value like say 8. If I replace this x with 8, will this be true? No. Because what we'll have is 8 is less than or equal to 7, which is not true. 8 is actually more than 7. Or let's say if you put say minus 8. If you put minus 8, what's the modulus of minus 8? Still 8. Is 8 less than or equal to 7? No. Alright, so once it's less than, then what will happen here? Whatever you have between the modulus sign here, 2x minus 1 is less than or equal to 7 or greater than or equal to minus 7. And we have a general rule. We have a general rule that states that if you have the modulus of x that's less than or equal to some constant k, then x would lie between the positive k and negative k. Alright, which makes perfect sense, as I showed you earlier. So we apply the same principle here. 2x minus 1, all of this would represent the x. It lies between the positive, in this case the k would be like the 7, the constant, 7 and negative 7. And we solve this. To solve this we can add 1 to each section. So let's add 1 to each section. So we have negative 7 plus 1. And we'll do that so we can remember we're solving for x. So we want the x by itself. So we add 1 to get rid of this negative 1 here. So negative 2x minus 1 plus 1 and 7 plus 1. So we add 1 to each section. And then negative 7 plus 1, what's that? Negative 6. And then negative 1 plus 1, that's 0. So we end up with just 2x here. And then 7 plus 1, that's 8. And then remember the aim of the game here is to get the x. So we divide each section by 2. So negative 6 divided by positive 2, that's negative 3. 2 into 2, that's 1x. And 8 divided by 2, that's 4. That's our solution set. So we are saying that any value between 4 and negative 3 would satisfy this inequality. So let's try. We can always try. Let's try a value that lies between 4 and negative 3. 1. Let's try 1. What's 2 times 1? 1. Sorry, 2. 2 times 1 is 2. So in the bracket here, you have 2 minus 1, which is 1. Is 1 less than 7? Yes. Let's try 4. Because we're saying x can be equal to 4, right? 2 times 4 is 8. 8 minus 1 is 7. Is 7 less than or equal to 7? Yes. Let's try 0. Because 0 lies between 4 and negative 3, right? 2 times 0 is 0. So what you have is negative 1. What's the modulus of negative 1? Positive 1. Is positive 1 less than or equal to 7? Yes, it is. Alright, so that's your solution. And again, you can always check your solution. And by the way, let me give you the case for the greater than. Give the case for the greater than. So what if this was a case? Modulus is greater than or equal to k. Then x would be greater than or equal to the positive value, or x would be less than or equal to the negative value. Alright, so this is for this. That's when you have the less than, and this is for when you have the greater than or greater than or equal to. In other words, think about it. Suppose I say the modulus of x is greater than or equal. Let me use the actual number 4. Now let me just draw a number line there. So we have 0 in the middle. We have positive 4 out here, and we have negative 4 out here. Good? So the solution set for this is that x would have to be more than a value that's more than 4. Like say, for example, 5. Suppose x is 5. If x is 5, then is 5 more than 4? Yes. Or suppose negative 5. Suppose x is negative 5. What's the modulus of negative 5? Positive 5. Is positive 5 more than 4? Yes. So in a situation like this, the solution set for this would be x is greater than or equal to the positive, or x is less than or equal to the negative. Alright? So if this was a problem, let's say the problem was that. Right? And of course these would still be your critical values. But what would be your solution? X is greater than or equal to 4, or x is less than or equal to 3, which is saying something different from saying x is between the values. Right? As a matter of fact, let's do another one where it's actually greater than or equal to. Alright, so here's another one. So once it's greater than, then the 3x minus 4 is greater than positive 6, or 3x minus 4 is less than or equal to negative 6. Alright, we solve. Group here, so we have 3x is greater than or equal to 6 plus 4. So 3x is greater than or equal to 6 and 4, that's what, 10. Divide both sides by 3. X is greater than or equal to 10 over 3, 3 and a third, right? Over here, grouping, so we have minus 6 plus 4, so 3x less than or equal to negative 6 plus 4, that's negative 2, right? Divide both sides by 3, so x is equal to minus 2/3. So again, we have, and if it was less than, it will be between the two values. So we have two cases, either when we have the less than, the constant, and when we have the modulus is greater than, well, it could be greater than or equal to the constant. So in this case, x is between the positive and the negative value of the constant, and in this case, x is greater than or equal to the positive value of the constant, or x is less than or equal to the negative value of the constant. So in this case, this was a greater than situation. So the 3x minus 4, what's in the bracket here, is greater than or equal to the positive of the constant, which is 6, or x is, or what we have here on the left hand side is less than or equal to the negative of the constant, which is minus 6. I will solve each equation separately. Let's look at the case now where if it's less than. So if this was a problem, then 3x minus 4 will be between the positive of the constant, which is 6, and negative. And then we need to get the 3x, the aim is to get the x by itself. So we can add 4. Let's add 4 to each section, add 4 to each section. What we end up with is 3x, because negative 4 cancels positive 4, right? 6 and 4, that's 10. Negative 6 and positive 4, that's minus 2. And then we divide both sides by 3, since the aim of the game here is to get the x by itself. So 3 into 3, that's 1x, right? So 10 over 3, that's 3 and a third, right? And then that's negative 2/3. So notice in this situation, x is between the two values. And this will be our solution if it was less than 6.